Well, we have another question here, question 5.2. The question says that the graph of a parabola f has x-intercepts at x equal 1 and x equal to 5, g of x equal to 4 is a tangent to f at p, the turning point of f. Sketch the graph of f, clearly showing the intercepts with the axis and the coordinates of the turning point. Okay, let's first, before do the graph, let's first work it out. We have like question 5.2. It said that the x-intercepts are x equal to 1 and x equal to 5. Now, with this information, we know that a parabola, okay, can be given in the form of a quadratic equation like ax squared plus bx plus c. It can also be expressed in terms of turning point formula, which is given by a open brackets x plus, it depends, some people use h, some people use p. I want to take this one, p squared, no, not plus but minus p, like that, to the power of 2 plus q. And it can also be expressed in terms of intercept form, which is x minus x1, okay, and then x minus x2, x1 and x2 being the intercepts of the parabola, okay. So those are the intercepts. Now in this case, it's going to be much easier for us to use this formula. Now, I want to say here y equal to a open brackets x minus x1 here, and then x minus x2. So now sum in the value of x1 is just 1, and then x2 is 5. Now, what else do we know from the question? It is said that the graph of f, of a parabola f, has intercept at this point and that point, and g of x equal to 4 is tangent to f at p, the turning points of f. Okay. It is said that 4 is g of x, 4 is tangent to f at p, the turning point. So 4 is also the turning point, the y coordinate of the turning points, the y value of the turning points. Now, how can we get, if we know the y value of the turning points, so we also need to find the corresponding x value of the turning points, okay? The x turning points, their formulas are roots. X turning points can be written as negative b over 2a, and x turning points can also be written by the difference, the average, I mean, x1 plus x2 over 2. Now, between the two formulas, the right formula for the turning points here would be this one, because this is much useful. So in this case, it's useful. So now I want to find the turning points. Maybe I just need to move my board a little bit this way. Okay, and let me just move this a little bit down there, and this part also. One, and because of space, I take this also like that, and then I'm gonna take my -5 there, and then close the brackets here. Et voilà. Now, over here, I can work out my turning points. The x coordinate of the turning point, which will be 1 plus 5 over 2, which means that the xTP equal to 3. So now we can substitute the values of the turning point over here. So it's going to be y equal to a. Okay, the y coordinate of the turning point is 4. So I can sub in the value 4 there. So 4 for y, and then 3 for x. So this will be 4 equal to a open brackets. This 3 here minus 1. 3 minus 1, open brackets, 3 here also minus 5. minus 5. And then 4 will be equal to a times 2 times negative 2. Okay. And then that makes 4 will be equal to negative 4a. And then we can find a if we divide both sides by 4. Okay, by negative 4 actually. And then that makes negative 1. So we also get the derivative of a is negative 1. Therefore, we can write our equation would be y equal to minus x minus 1 open bracket x minus 5 in the x-intercept form. Or we can also write it like if we times this, maybe negative x squared minus 5x minus x plus 5, which will make negative x squared minus 6x plus 5, which will be negative x squared plus 6x minus 5. That's the quadratic equation now, but it's not really what we wanted to do. I just showed this for sake of illustration, but we needed to find x and a, and then a tells us that a being negative, it tells us that the parabola has an inverted U shape. We could all this as meanings. Inverted U shape, the parabola will be like that. Okay, x-intercepts are x-intercept, negative 1, 1, 5, just intercept. And then y-intercept will be negative 5. So now we can draw. So this is the y-intercept. Y-int. Now we can draw our graph. Okay, I'm gonna take my ruler. We draw the x. Now I need to draw the y-axis. I'll draw somewhere. Okay, so this is like the y-axis, and that's the x-axis. Now the intercept, as we said, the intercept were like 1 and 5. So each one is here. 1, 2, 3, 4, and then 5. So 1 is here, and then 5 is there. Now the y-intercept is those are the x-intercept. The y-intercept is negative 5. So let's say 1 is here, 2 is there, 3 is there, 4 is there, and then 5 will be there. Negative 5. Oh, sorry. Flow. Anyways, now you're welcome. Thank you. So we have like the intercept here, as we say, the x-intercept, and then the y-intercept is there. And now we know that this would be an inverted U shape because a is negative, is less than 0, negative 1. And then the turning points was, they say that g of x, what the question says again over here, it says that g of x is equal to 4. Is tangent of f, and then we did find the turning point. The turning point was by 3 there, so 3 is over here. The midpoints of 1 and 5, so 2 will be here, and then 3 will be there. So 3 is where the turning point is, and then 4 that will be like, if this is 1, so 1, 2, 3, 4. So it must be somewhere. That's so now the graph would then be, guys, we cannot draw the graph like this of a parabola. Please don't do something like that. Okay, don't do that. This is not a parabola. the parabola must be a curve. So over here, it must be something like round a little bit, like that by the tip. So something like this, approximately. Oh la la. We know that it will cut here, it will cut here, it will cut there, and it will cut there also. So now when we try to make it there a bit round, and then it comes here, it cuts by 5, and over here also it will cut by 1, and then it must also cut there by -5. So it must be something like something like that. Now we can draw our parabola like something like this. Okay, you won't be accurate, but as long as it may look like a parabola, that's fine. Thank you.